Hey folks, can AI coding agents do test-driven development? That is what this video is all about. So what exactly is test-driven development, or TDD? It's a process that many experienced engineers use to avoid gold plating, to stay laser focused on the problem at hand and not invent irrelevant code that won't be used. It follows three phases called red, green and refactor. And the red phase is where you write a failing test, one single failing test that describes the new functionality you want to implement. And the second phase then is the green phase, where you write production code to have that test succeed. You write the simplest test possible or the simplest code possible to make it work. And the third phase is called refactor, where you clean up after yourself, remove duplication, stuff like that. And only then you proceed to the next test. So it's a really iterative, short feedback cycle. It's a really iterative process. And if you have been using AI coding agents for a while, you might have noticed that they don't work this way. They prefer to work using bigger steps. They do big bang things, from nothing to all the code and tests available. And a lot of engineers have been trying to get AI coding agents to actually follow test-driven development. And the most commonly used way to do this is to use prompting techniques. The father of test-driven development, Ken Beck, who wrote the literal book on it. He has a system prompt online, I'll link it in the show notes below, that really strongly encourages coding agents to use test-driven development. But I have had mixed results with that myself. These agents, their instruction following, especially for test-driven development, is only average at best. They give it their best effort, but they give up after a couple of times. So no great success. And that's when I started to look around the internet for stronger guardrails to really enforce the test-driven development process. And that is when I found tdd-guard. So is it worth looking at? Is it worth using? Today we'll figure that out. So let's dive in. So let's first go over the experiments we will be running and then dive in, shall we? So again, I am utilizing the eShop on Web reference application. It's a somewhat large .NET application with good practices. And it's a good starting point for experiments like this. So that's what we will be using. And let's quickly take a look at the code. It has some domain-driven design concepts like application services and aggregates, stuff like that. Not super important for the experiment, but in the big picture, we have application services and they have use cases or scenarios where you can add an item to a basket or delete a basket or transfer a basket from an anonymous user to another user, stuff like that. And it's almost always the same. We look up data in the database using repositories. Then we delegate to the aggregate for business logic, stuff like adding items, as you can see here. And then we do persistence operations, and that's it. And maybe another interesting aspect is the tests. I like my tests to talk to the system on the application service level, so the basket service that we just saw. And I like using Fluent APIs for test data, like test data builders, which is what you can see here. We create new baskets. We add them to a stub, a fake repository that is in memory, and then we exercise the system under test and we validate. So this is the way I like to write code myself, and this is what we will be using for the experiment. Now, let's take a look at what we are going to do, with a prompt suggesting TDD and with the tdd-guard library really enforcing it. So let's take a look at the desired feature we're going to build. And that feature is called splitting a basket. I came up with this myself. It's a totally fictitious use case. But I want claude-code to implement splitting a basket. Splitting a basket results in two different baskets. And the original basket has only cheap items that cost $100 or less. And the new basket will have all the expensive items. That's the general gist of the feature. And we're going to strongly suggest to use test-driven development, as you can see here. And we're going to point it at relevant code, like the tests we just discussed and the service code we just saw. And I also, when I'm programming with AI coding assistants, I like to give method signatures in the code or in the prompt itself. It doesn't really matter, but I like to give it a couple of breadcrumbs so it knows what I'm looking for. And then, of course, in every story, there should be some acceptance tests or some acceptance criteria. And here I list three different ones, like only splitting a cheap or a exclusively expensive basket should result in no change because there's no different buckets. And then the final one is the real logic, where if you have a mix of expensive and cheap items, we should be able to split a basket into two separate ones. And then I give it some help on how to run unit tests. And in the case of tdd-guard, as you can see here, we have to do a bit of black magic, but that's just to help claude-code along. So that's the feature we will be building, once with just this prompt and once with the tdd-guard library in place. And we'll see how these two approaches compare later on. So let's go. All right, so now let's first try the best effort approach. No extra tools, no MCP servers, nothing. Just vanilla claude-code and a carefully crafted prompt where we really try to nudge it to write unit tests. And see how far we get. So let me put on the timer. So we have an idea how long it takes, and we have no changes. All tests are passing, and we have a clear claude-code. At least now we do, so let's take a look at the results. So it'll implement the feature following TDD principles, or so it says. Let's take a look at the to-do list here. It's gonna take a look at the existing implementation, then it's gonna write all the failing unit tests. So this is not test-driven development. This is something test first, sure, but not test-driven. The iterative loop is not here. And then it's gonna run the unit tests to verify the implementation. So that sounds like a good plan, or a good enough plan at least. Okay, it's come up with some unit tests, so let's take a look at those first. It's not compiling, of course. It has not implemented any stub methods, and it's figuring that out now. As you can see, it tried to run the tests, but it's not compiling, and it treats that as a red phase apparently. So now it's going to implement all the production code in one big bang. In the meantime, let's look at these tests. We see our acceptance criteria return, so it's the criteria we listed. This is the interesting case where we do an actual split. And it even added a new case, like if we cannot find the original basket, then, so yeah, okay, so that makes sense. Okay, so the test looks good enough. It already changed the aggregate, the basket. So let's take a look at that. It added a split method where it looks up expensive items. And if we don't have a split to do, it returns null. So yeah, that's what I would have expected from the method signature. So this looks good. Creates a new basket and adds all the expensive items. So this looks correct. I would not do this myself. I would remove all the expensive items, not do the query again, but okay. That's a small detail. We could fix that in post. And now it's working on the service logic. We are running our unit tests again. There, I was waiting on my basket service diff, but there it is. So let's take a look at the split method on the service. We look up the original basket. We return not found. We have our threshold hard-coded here. We delegate to the aggregate. I'm not sure about this update async, but if that is how this code base handles updates, yes, it is. So yeah, that's correct. Don't like this optional basket thing. Why would there be a nullable basket? That is not what was in our prompt, right? No, that was not what was in our prompt. So it invented a method signature. So there's a couple of problems with this, or minor details. I would not call this problems, but it implemented the feature in, let's say, 4 minutes, and it did not do test-driven development. It did test-first development. All right, now let's try that again, but this time let's enforce TDD using the tdd-guard library. So I reset my code and I configured tdd-guard properly. More on how to do that later in the video, but let's first showcase it. So I'm going to grab my prompt and start a timer so we can compare a bit. And I reset my code base to the before state, and let's fire up this prompt. So it's going to build a plan. Let's take a look at the to-dos. Look at the code, write all tests, implement the aggregate first. So there's a couple of interesting things here. It's going to write all the tests again. So it's the same as the previous attempt, which is not strict test-driven development, that you're supposed to write one test at a time and iterate. So tdd-guard will flag this and will block it. And there's a second interesting observation. It's working bottom up. So it's starting from the aggregates and the entities and then working up to the services. And I configured tdd-guard to work outside in. So it should also detect that we're changing like leaf nodes in the code base first instead of working top down, outside in. So as you can see, we're running hooks when we're trying to edit code or when claude-code is trying to edit code. And this is how tdd-guard works. Before it allows file writes, like you're seeing here, it's calling a hook, and this hook is running the tdd-guard logic. And as you can see, it detected the first problem. We're trying to add 4 unit tests at a time when we should be focusing on them one at a time. So now, instead of strongly suggesting through prompting that we should follow TDD, which doesn't work, as you can see, we're now enforcing test-driven development by this library. So claude-code now has no option to not follow these instructions. And as you can see, the green traffic light here, the first test has been allowed to enter the system, so we should see changes. And now it's running the tests. Now we're in the red phase. We're trying to run the tests and see that they fail. And let's take a quick look at the test that has been generated. It's the first acceptance test, the one with the cheap items only. And as you can see, it's not compiling. So we're in a deep red. It's not even compiling. So the next step would be to implement stub methods. So the test compiles but fails with an assertion error. And that's what's happening right now. But as you can see, it's going to try bottom up while I prefer top down. So this should also get flagged as a TDD violation. It should start working from the service and then go down level to the aggregates and the basket code. Yeah, so it gets flagged correctly. We're working bottom up and we prefer outside in, top down. So now it gets nudged again. It's implementing split stubs in the aggregate. So that's a bit too soon, but it's allowed because it's really small and I allowed for some leeway to not doom loop too much. And now we're going to get to the real entry point of the system, the service logic, which does the lookups in a database and delegates to the aggregates. So it's a stub method, so this was allowed. And now the code should compile at least and fail with a relevant assertion error. Or actually, the test should pass, I guess, for the simple case we're doing it right now. So that's the first test case down. Now we should be in a refactor phase. It's trying to do like a... the tests are green, and now it's trying to add in the full implementation. But tdd-guard should flag this again. It should write a new test that forces this behavior to be added. Yeah, so it's flagging again. We're trying to add a lot of code without a failing test. So it's focusing on the next test now. This is exactly how I would do it when if I was coding this by hand. And there we go. A second test with expensive items has been added, which is a bad test because it'll pass by default. Yeah, so it's going to add a third test that should fail, which is the interesting acceptance test, the one with both cheap and expensive items in a basket. So it was allowed to add this test. Now we can proceed, which is the mixture case. Yeah, so all is proceeding as expected. That's a bad test. It's not asserting that much or too little to my taste. It's only counting the number of baskets in the system, not validating whether they have the correct line items. And I'm hitting my claude-code limit. Interesting. So we're in the basket service, we're looking up the basket and we're splitting. yeah, that seems like a decent implementation of the service logic. All right, and the aggregate logic has been implemented as well, which this looks correct, but we have no test that is validating the correctness. So that's an interesting loophole that claude-code was able to find. Oh, now it detected that it like wrote a bad test by itself, so that's cool. Now it's trying to update that test I was not happy about. Okay, and yeah, that looks better. It's a basket with 2 items, so yeah, that all looks correct. And now we're running the tests again. They should be green. So yeah, Claude is done. And it took 10 minutes, which is longer. So now let's go to some conclusions. All right, now let's look under the covers and see how exactly this library works. So first things first, you have your regular AI coding assistant. I use claude-code, but it doesn't matter which one you use as long as it has hook support. And I had to configure a hook that whenever claude-code is trying to do a write on a file, so adding a new test, adding new production code, or refactoring code, changing code, then this hook should trigger, and the hook will only like call the tdd-guard library. It's a npm package. So that's the first thing you need to have in place. You need to download tdd-guard, the npm package, and you need to install some hooks in claude-code. Now there's a third ingredient, and that is specific to the language you're programming in. I do a lot of work in .NET, so I wrote my own .NET component for tdd-guard. But there's already support for Python, TypeScript, I think, Golang, and now, or soon at least, .NET as well. And that's a swap in or a drop in replacement for the .NET test framework. So that's how you run unit tests in .NET. And this runs those unit tests, but also like writes the test outcomes to a specific file in a specific format that tdd-guard understands. And then there's this shared folder in the .claude directory where all the file updates get written to and where all the test outputs get written to. So there's a bit of state in there that allows tdd-guard to work. And now for the magic, the really cool part. How do you figure out if you have like file edits and test results? How do you figure out whether or not you're following the TDD process? Because it's hard to encode that into actual code, right? It's hard to really codify the rules. Well, guess what? AI is pretty good at fuzzy problems like this. So tdd-guard uses internally its own LLM, its own coding agent, or its own AI agent. And internally, it spins up a new instance on claude-code that acts as a judge. So for every change, for every time this hook triggers, it looks at the current test outcomes, it looks at the current file changes that are being requested, and it starts a new AI that will act as a judge to verify whether or not like the TDD process is being followed. So the tdd-guard library has a lot of prompts that get shot to this or fired to this judge, so it gets programmed to judge accordingly. So let's maybe take a quick look at those prompts. This is one of those prompts, sorry for the light mode, but it states like, these are the core principles of TDD, and you recognize the red phase, green phase, refactor phase. So this programs claude-code or any other LLM to be like judge for whether or not the TDD process is being followed. And then when this judge like is done, it spits out some JSON, and that gets returned to the hook, so to the original claude-code instance, and that then gets blocked or can proceed with work. So it's a really nifty design, a really cool use case of AI judges. So what did I think about tdd-guard? Well, first things first, I love the philosophy of this tool. I see a lot of people struggle and try to enforce or try to get claude-code to follow test-driven development by using prompting techniques. And yeah, they all fail. So this is the first tool I found that really enforces it and puts in guardrails that cannot be bypassed. And I love it. But there's a trade-off. While I think that the output, the code quality is of a somewhat higher standard, because we're forcing a claude-code to not freewheel and not like invent methods that are not necessary. So the output is slightly better than not using these tools. But the library, just because it calls an AI judge in the background, it eats tokens. Every file edit will call an LLM to like validate whether or not we're following TDD. And also because of that, it's slower because there's like a separate validation going on. So for me, the trade-off is not worth it. But if you are looking at a way to enforce TDD, this tdd-guard library is the best I found out there. So please take a look at it. So have you been using test-driven development in the past? And have you found a way to make it work with AI coding agents? Please let me know in the comments below, and I'll see you next time. Bye-bye.